Welcome to Akulmac Live. Uncover the shocking truth about the Mini-Neptune. The new JWST research is completely overthrowing everything we thought we knew about these common exoplanets. So astronomers previously believed that the Mini-Neptunes were superheated magma ocean beneath the thick atmosphere. But thanks to groundbreaking data from the James Webb Space Telescope, the mystery might be solved. So let's find out more. Hello, so how are you doing today? So welcome to this channel. Today we are diving into the cosmic mystery that had puzzled astronomers for years, and mystery concerning the most common type of planet in our galaxy, the Mini-Neptune. So these worlds are unlikely anything in our own solar system. So they are bigger than the Earth and yet they're smaller than Neptune, shrouded in a thick, dense atmosphere of hydrogen and helium. So their sheer abundance suggests that they are the galaxy's default planet. But there are a crucial piece which is missing from their profile: what lies beneath the thick atmosphere. So for years, the leading scientific paradigm was that the Mini-Neptune were fundamentally lava world or magma oceans. So they are rocky cores heated by their close proximity to their stars and intense atmospheric pressure, were thought to be entirely molten and scorching planet-wide sea of liquid rock. It is terrifying, beautiful, and compelling picture. But thanks to revolutionary power of James Webb Space Telescope, that the picture is now being completely rewritten. The Mini-Neptune mystery, yes. So it might be just solved. We are in that process. So first, let us clear on what we are talking about. The term Mini-Neptune or the sometimes sub-Neptunes refer to the planets that with a radius generally between 1.6 and 4 times that of Earth. So in our solar system, we jump from rocky Earth and Mars straight to the gas ice giants Neptune and Uranus, and the Mini-Neptune fill that huge gap. So magma ocean theory was the standard model of many of these planets, especially the warmer one. So it was based on few logical assumptions. So first is a planetary formation. Like Earth, these world would have started off with the molten surfaces due to heat of assertions and massive impacts. The thick atmosphere, that is, it is being believed, and their substantial hydrogen helium evolve acts like a greenhouse effect and efficiently trapping the heat. So the high density which is combined mass and radius measurement suggested dense and rocky components. So thinking was simple, and this dense and heat trapped atmosphere molten for millions of years, and creating a permanent super hot magma oceans interfering directly and interacting was thought to be key to their entire evolution, even potential limited to how large this planet could grow. So how do we see the past and a thick atmosphere to figure out what is on the surface of a planet tens or hundreds of light years away? The answer is so far often the case now is the James Webb Space Telescope. So JWST isn't just a bigger telescope. It is a revolutionary infrared machine. It is designed to look into the faintest heat signatures, and crucially, the exoplanet perform transmission of spectroscopy. So when the exoplanet passed in front of its star, JWST analyzed the star light filtering through the planet's atmosphere. So molecule in that atmosphere, things like water vapor, methane, or carbon dioxide, observe some specific wavelength of light, leaving a chemical fingerprint. So a recent JWST observation of a key Mini-Neptune like GJ1214b begins to show unexpected chemical signature. The atmosphere appeared to contain larger, heavier molecules and then simple hydrogen and helium, suggesting a high means of molecule weight than the anticipation. So this seemingly small detail completely threw an old model into a chaos. So let's find out why. And because a heavy atmosphere means a much heavier blanket of gas and pushing down on the surface. So this brings us to the core of a new discovery. Scientists, including the lead researcher, Professor Eliza Campton, and her team, took into new JWST data realization of heavier, more complex atmosphere and applied to the complex internal structure model of Mini-Neptune. So they were working with a paradox. We know these planets are hot and heat melt rock into magma, but we also know that the pressure can counter heat, forcing material to solidify. So think of it like this when we just think deeper. The deep beneath the Earth's surface where temperature are absolutely scorching and immense pressure keeps the inner core solid and compressed rock and not liquid. The new model suggests the weight of the newly confirmed heavier, thicker Mini-Neptune atmosphere creates such tremendous pressure, far exceeding what we see the Earth, that it reverses the melting process. So in other words, the pressure at the boundary between the gas envelope and the rocky mantle is so high that it forces the silicate to transitions from molten magma back into the solid. A high pressure phase such as post perovskite kind of pressure. The conclusion is striking. A substantial portion of Mini-Neptune populations previously thought to be floor is lava world may actually have been solid surface, rocky, compressed, utterly uninviting but solid nonetheless kind of atmosphere. So this finding isn't just a neat piece of trivia. It rewrites the exoplanet rulebook, and that has profound implication for how we understand the planetary evolution and formation. So planet formation model, let's discuss little further. Scientists have long struggled to explain the existing of Mini-Neptunes. So this new solid surface model changes the entire energy budget and structures. A solid surface means no ongoing interaction between magma ocean and the atmosphere, which affects the planet and the chemical evolution and how much gas it is hold on over the time. So kind of whole gas measurement is also very, very important. So this new understanding help us refine models on how a planet grow, stabilize in their earliest and most chaotic phases. So the search of habitable world, Mini-Neptunes are often at the center of discussion about the world's planet, and that might have vast liquid ocean under their hydrogen rich evolves. So that is something which we are actually working, the scientists are working. So if the interior is solid and high pressure rock layer, it changes the entire potential of internal heat flow and water rock chemistry, which are crucial for asserting habitability. While these specific planets are likely to hostile, understanding the transitions point from magma to solid gives us a better context for finding a Earth-like world. So the radius valley, when we go further, and astronomer observed a crucial gap in the exoplanet sizes known as radius valley. So these planet, where the planet between 1.5 and 2 times the size of Earth, are rare. And on the leading theory suggests that this is the point where atmospheric pressure actually escape, and due to the stellar radiation, and stripped away the gas from the small mini Neptune. So this new insight into the internal pressure and the phase transitions add another layer of complexities to those of crucial dividing line. So the James Webb Space Telescope continues to surprise us. It is not just finding new things. It is fundamentally changing the most basic scientific senses on the planetary physics that we have developed over the past few decades. So the discovery that the galaxy's most common planets may be solid, high-pressure world instead of molten magma ocean is stunning testament to the power of new technology like JWST and the relentless curiosity of planetary scientists. So it reminds us that our own and whole solar system is not only the template for planet formation. The universe is full of exotic, strange, and entirely unexpected world that continues to redefine what a planet can be. So Mini-Neptune mystery may be solved for many, but thousands of new questions have just opened up. So what do you think about this shocking discovery? And let us know in the comment below. If you enjoyed this deep dive into the exoplanet research, please hit and like the button, subscribe our channel for more space and science news. So click the notification bell so that you don't miss our next cosmic update. Thanks for watching, and we will see you among the stars in the next episode.